Here's the capacitors that I've changed. This one, this one, this one, this one, and remember there was the two blocks that were one here and one here. So that'll be these two guys here. One was a dual capacitor, one was a single. This one here is a 0.5 microfarad. I don't have one, so I'm not going to start on that yet. And then way down at the bottom, I'll try and point this down there if I can. And this guy down here, this block with the 6 leads on it, that is the filter condenser, capacitor, what do you want to call it. And I don't have a lot of information on it. The manual saying it's like a couple 1 and 1.3 microfarad. I don't know. So I'm going to pull it out and see if I can test anything on it before I don't know what I'll need, if I'll need to order anything or not. So, but that's what I'll do. I'll just unsolder all these guys here, and there's a couple screws that hold the thing in. Then we can test it on the bench. But I figured I'd just show you how everything's going. Everything seems to be good as far as with replacing all the capacitors. They're easy to use or to replace, and the nice thing about them is a lot of times these ones up here, they act as a standoff for the wires. Or in this case here, there's 2 resistors and a capacitor that are tied to it. They have nothing to do. They're on a dummy lead, but they're using that as the standoff. So if I would have taken that out and put a straight capacitor in, I would have had them on a standoff somewhere. So anyhow, that's that story. So let me work on getting this guy out of here, and then we'll go from there. All right, I got all the wires off of it, or unsoldered, or whatever. Then there's 4 screws. I took them off already, so this should just pull up. There you go. There it pulls up, and there's the wires. Oh, I don't see any markings on this anywhere that give up what it is. Let's see, it was in like this. All right, I found my little drawing with the layout here. So they're numbered as they go down the road. Odds on the top and evens on the bottom. And we know that where 5 is because it's this guy right here. There's no connection. There's no capacitor. You can see if you look in there, there's number 5 has no soldered connection coming out of it. The rest all do. Okay, so that's number 5. So the orientation, we could set it, would be kind of like this. That big 5 there. 3, 1, so 1, 3, 5. So 1, 3, 5, 2, 4, 6. Okay, so let's, using this meter, if we can prop it up somehow. Let's see what we get. That's telling me that between pins, oh poop, there's a capacitor. Let's see. Let me see, maybe if I point you more downward, you'll have a better view at the meter. Try not to make you too seasick. Alright, so let's go in between pins 1 and 2. That would be this guy here and this guy here. And we're showing let's make sure we get a good connection here. (2622 picofarad. Let me just write that down. 2622 picofarad. That's between 1 and 2. Now between 1 and 3. So that would be these guys up here. Make sure I'm not touching anything here. 19141 nanofarad. That's a weird one. 19142 nanofarad. And I think they want it all in microfarads, so we'll have to convert all that and see. But all right, then 1 and 4, still 1. That's 2. Here's 4 down here. 12,677 nanofarad. 12,677 nanofarad. Alright, and then lastly between pins 2 and 6. So let's see. Here's 2. And here's 6. Oh, like 138.58 nanofarad. 58 nanofarad. All right, let's see what we get from this. So here's what we have compared to what the paper has. I don't know what we're looking at here. Alrighty. This camera's so hard to get an idea of what it's really looking at. Alright, but this is where we're looking right here. And I don't think I have the ability to zoom in anymore, but between pins 1 and 2 we should have 1 microfarad. Between pins 1 and 2 we have 0.0026 microfarad. So that's definitely not a good thing. Between pins 1 and 3 we should have 1.5 microfarad. We have 1.91 microfarad. Probably close enough. Between pins 1 and 4 we should have 1 microfarad. We have 1.26 microfarad. Pretty good. And then between pins 1 and between pins 2 and 6 we should have 0.13 microfarad. Between pins 2 and 6 we have 0.13 microfarad. So number one's definitely way out of the ballpark, but that at least tells me that the numbers here that they're showing are consistent and correct. So I'll have to order some stuff, and I don't know if I'm going to take this one apart and restuff it, or it might be interesting to take it apart just to see what's in it. And I'll have to get the voltage, come up with a voltage rating for that also, for those capacitors. I'm sure if we're in the 600 volt range we'll be more than fine. Alright, let's go order some parts. Alright, it looks like by drilling out those rivets I was able to tap that cover right off, and then I can pull this plate off. And I don't know if you can see in there, it's really dark. Maybe when I get it out you'll be able to see better, but all the wires that connect to the plate where the terminals are, and inside there it's a bunch of that black tar. So what I'll try and do maybe is just cut these wires off and use a heat gun, heat this up enough, and see if I can pull everything out of there, because I don't need any of that stuff. Alrighty, got some capacitors in, and here they are on the bottom. And I found a schematic online that indicates the polarization for the capacitors that would typically be electrolytic, the higher value. And here's what we have here. As far as this goes, I started to clean this out, and as I was taking it out I realized that this can is very flimsy, so to speak. And you can see it was starting to get, just from me reaching in here, it was starting to get bent up along the edges here. So I thought if I do eventually get all that crap out of there, this can is going to be really flimsy. So my thought is, what I'll do is, see, I got that out enough, and this will fit back over here. That board is actually riveted in there, and it doesn't rivet to the can, so it's pressed in, and then when it sits here on the plate, that holds it in. Which reminds me, I gotta clean that before I put it back together too. So much to do. So anyhow, what I'm going to do is, you can see there's little bits of foil and everything else in there. I'll cut a piece of fiber, like almost like cardboard, and I'll put it in there and then RTV it in place, and that'll keep just over the period of time anything that might happen fall out, so it wouldn't possibly fall and short this. I think the likelihood of that's not very possible, but if it's going to happen, it'll happen. So I'll just put a little piece of fiber in here, glue it in, and then this piece actually just, I'm going to have to straighten out some of the metal here a little bit, but this will just sit right back on there again, and we'll be good to go and put it in. So let me get at it. There's no sense in you watching me cut a piece of fiber with scissors and fight with this. So I'll be back. All right, there it is, nicely back together again. As you can see, this piece is just, it's not, the rivets don't hold it on. So put it back in here. I want to make sure I get it set the right way, because even though I marked the case, when I took that off, I didn't mark that. So it doesn't matter as long as it gets on there the right way. Otherwise, I'd have to change all my wiring around, and that just doesn't work. So let me see. I have to flip it up and see what we have here. Because I don't want it like that. I want it on the heavy end. The transformer's done. There we go. So I did take a picture of it, and I'll have to look at the picture and be sure. And I think I also drew it somewhere, but I want to look at the picture. And then I'll be sure I have it in the right way. Then we'll put this in. All right, here we are once again into the loudest room of the whole world. Air conditioning's running, the dehumidifier's running, the birds singing. Probably hear all kind of other stuff other than my babbling. All right, so here we have where we left off. This tube here, the plate of this tube, should have about 200 and some volts on it. It has 0 volts on it. So the voltage comes from the voltage comes from the transformer up through here into this resistor capacitor joint. This was the first item we found bad, and then the output goes from here into this transformer right, I don't know if you can see, right here, and then that's one side of the transformer. The other side of the transformer is right here. So everything's behind this guy here, really, but it's right behind here. And it comes up on a wire to this plate right here. So I have about 200 and some volts on the primary side, well, on the input side of the primary, but on the output side of the primary, where it goes to the plate of this tube, I have nothing. So of course I'm testing the primary coils from here to here. I have OL, which would be infinity as far as ohms go. So it's open. Now if you remember a couple videos ago when I was looking, I found a little piece of wire down here, so it looks like transformer wire. I wonder what that's from. Well, I guess that was foreshadowing, because it was probably from this. And I'm thinking when the capacitor in this unit right here shorted, it probably allowed DC to come straight from the transformer straight through, enough to give this a blast, a little lightning strike, and that probably broke the wire. Now it also goes to this transformer, I believe. Would you believe? Yeah. But fortunately, remember, this had a resistor in it too, and the resistor, although it was only a couple hundred ohms, like 200 ohms, it was still intact and working, so that possibly saved this transformer's life. But to get this one out, I've already taken the screw out of this this capacitor here, and I'll move this out of the way. It looks like I take this screw off down here. There's a screw down here, which also serves as the ground for that transformer. And then I'll unsolder the bolts, the bolts. I'll unsolder the internal wires for it here and here. And in theory, that should all pull right out of there. And we'll take a look at how bad it is. Alright, so there it is. I pulled the bolt off. I unsoldered the 2 resistors from this capacitor right here and moved it up out of my way. And was able to get in here and solder all the wires from there. And let's see, this one actually broke while unsoldering it, but that's okay. Took the screw out, a little 1/4 inch screw, and now this guy's going to come out here like so. And we'll take a look around before we really touch anything. The secondary ohm check's fine, but the primary ohm check open. When I tested them, they were really far out of spec, and this guy here, the yellow top's not even called out anywhere. But strangely enough, the series resistance of these ends up being about a meg, and each one of these is supposed to be 500 meg. So this is almost a meg, and this is about 1.5K or something. So I don't know, that's probably somebody's all they had. All right, let me look into this a little bit better, and I'll be back. Alright, I'm going to try and show you what I found here, if I can, before the battery in the camera goes dead. I'll be looking through this magnifying glass here. And I don't know if you can see these 2 wires hanging down there and there are disconnected. The light's probably right in the way, right? And the other 2 wires on the primer. I don't know if that's the only issue, but it is an issue. So if I can get them back together, we'll see if we can get this thing working. So stay tuned. Alright, let's see. There's some modifications to this, and basically, oops, to glue that down a little bit, but not that worried about it, and I'll tell you why. Where you can see the discoloration where it's dark here, it burned both the top and bottom, or top and bottom. And I unwound till I got to solid wiring again that I could wire in, and it actually removed about 6 windings, 3 from the top and 3 from the bottom. So yes, I know that changes the resonant frequency and the whole operating characteristic of this. However, probably the only thing that works worse than that is no transformer at all. So this will help me diagnose a little bit further what all we need, and I guess if I get really crafty, I can try my hand at winding a transformer, because it's just a primary actually that looks like the easier of the 2 to wind. And I did this years and years ago when I worked for Union Switch and Signal. Had to wind transformers. It was pretty interesting lost art. I mean, it takes a lot of practice. It'll probably take me a couple of times to do this to succeed. But anyhow, I'm going to throw it back in and then continue on with my diagnostics. I want to check those resistors that I had set earlier and double check them and put the right values in. While I'm here, might as well go ahead and do that. Alright, so I think what I'm going to do here now is I'm going to feed a signal into the antenna, in the antenna lead here. Can't really see it. But, and then it comes through here. It goes over the, I guess you'd say the volume is really the RF gain, because if you look here, and I can show you on the schematic in a little bit, but the The antenna lead is basically attached to a potentiometer with volume control, which comes in, that starts your lead into, this would be the first I or RF transformer. So what I'm going to do is just check it all along the way and see what I get, and then I'm starting off right now with, like, I don't know, half a volt maybe right here. I don't even have the radio powered up yet. We're just going to see what we can hear on the signal tracer. I have a story about that as well. Let's see. So turn that on. Let me turn the output on. It'll do a little bit of modulation so we know we have it. I'm using about 800 kilohertz. So let's just see. And I'm actually have a little, you can see a little resistor here. I'm sorry, capacitor here, just in case I grab onto anything that has any high DC voltage on it. So just about any value of capacitor will work. I think I'm using a 0.1 microfarad. That's just to block any DC. So let's just look and see. My modulated signal is 100 hertz. That to me just sounds like noise, like an AC hum. So I'm going to turn it up to about 1,000, so we'll know it when we hit it. Let me turn that. Let's see. AM frequency. Oh gosh. Turn that up. All right. There, that's more annoying. All right, I can probably turn that down considerable. So let's turn the modulation off and turn the signal down to, that's 100 millivolts. Let's see what we get here. Turn the mod back on. All right. We can hear that. So we got at the antenna lead. Let's check it coming into the, here's where it goes into the resistor. Here's where it comes out. We'll make sure that works. Yep, that's working. So then the first CAN transformer. I have to light it up in here a little bit so I can see what I'm doing. Here it is here. I don't have the radio powered up at this point because there's nothing, and I can show you we haven't got to anything yet that needs power. That would be this first tube that we're going to be checking here. So let's check the output of that transformer, and that would be going to the grid of that tube. And I already know this because I'm looking for the wire that goes up to the grid. It's right here. All right, don't have much of anything there. So let's see if I change the tuning dial. That turned up all the way. Let me. Oh no, now the AC is going to kick on. So let me actually get a lead here. And I'll get on this right here. So I don't have to hold it. Let's see. I'm actually going to pump the voltage up a little bit more so I can hear it better. Because when you get a little loss coming through that transformer. So I went down to about 100 millivolts. Let's go back up to, like, I don't know, we'll go to 300. 300 millivolts, turn the mod back on. There we go. Okay. Well, there it is. So we're way at the end of the dial here. So something's out of alignment. But I'm going to actually knock this down maybe to 800 kilohertz. We'll knock it down to about 500, so it's closer to the middle of the dial. We'll worry about alignment later. Now we're just worried if things are working. So let me knock this off. And frequency. There's 600. We'll leave it at that. All right. Modulation back on. signal way back down again. What am I looking for? Amplitude. There's 100 millivolts again. I'm going to turn the signal down even more because that's still pretty strong. Because we haven't even gotten through the first amplifier yet, so let's see. I don't know, we'll go. Okay, there's 50 millivolt. That's pretty good. We can hear it through there. Okay, so now is the first time we're actually going to come to an active component. So the first thing we're going to want to check, this is going into the grid on the first amplifier, this guy right here. So we're going to want to check the plate coming out of it. So now at this point I have to fire it up. So let's fire this thing up. Make sure everything's plugged in that it has to be. Give it a couple seconds to warm up. Now we're going to look at the plate of the first RF amplifier, the first number 24 tube. And I believe if memory serves, it is going to be the top right hand corner. And again, I'll be going through a capacitor because there's some considerable DC voltage there. Let me turn all this crap on. Why am I getting so much noise? Make sure right off the plate and goes to the transformer. That'll be the transformer that I had to fix before. So let's see, maybe if we just go to the grid of the next tube, we can be on the other side of that transformer. So I don't have the tube in, I only have the first tube in, so I can actually get to the grid up here. Looks like I had to move things a little bit, and that could very well be because I had to change that transformer some. I think I would have probably at this point expected more gain. So let me look there. Grid on that transformer. Let me compare it to the grid of the one before it. That's the first stage. I mean, there's slightly more gain. Alright, so, but anyhow, we know that we have gain, or we have to the second. So now I have to come the output of the second, and that means I'm going to have to put that tube in. So let's see, that comes out of there. It goes to that transformer. And yeah, I'll have to put the second tube in, because now we want to check the output. So we know we have a signal going into the grid of the next transformer. So far so good. Let me turn this thing off and power it on. And I will plug in a tube. Hard to see what I'm doing here, but should be right there. There it is. All right. Attach the grid wire. So now I have another amplifier in. So now we'll turn it back on again. Let's see what we get now. Give it a minute or two. Check the voltage on the 71 tubes. This is just something I wanted to check before the plate and the grid voltage on the amplifiers. Alright, so to sum that part up, I know that the signal's getting through, so I think I'm going to go ahead and get that transformer. Let's turn this on DC volts, and on the transformer side I only have 7 volts. The transformer side is on the 71s, that's the grid, and I think it should be about 50 some. Yeah, 50 volts. Now on the plate side should be about 200 and some. 215. Let me check that. The plate side on this goes to the outside, so this is probably it here. Let me set my range. 230. Pretty close. That'll be pretty close. Check the no grid voltage on that. So the plate voltage on the last 24. It should be, I'll check it right here. Yeah, it's 112. It should be 35. Of course, there's no tube in there to draw it down a little bit either. But okay. Shut that off. That last 24. Take a look at the grid of the 27 tube right now. Let me put that last 24 in, which is the demodulator. Let's see how to plug it in. There it is. That last 27 goes to looks like it's gonna be that one right there. So we'll just take a listen to what's going on right there, again through my capacitor, so it hopefully doesn't fry anything. Turn my output on. Oh, very nice. we've got our signal out, and very strong, very strong. So we have our signal all the way out to the first amp, the first audio amp. I guess it's like a driver. After that, it goes through this transformer to the audio power amps right here. So that just confirmed everything's working up to this guy. And on one of my other videos, we checked it. So we'll light up the schematic a little bit and take a look at everything. And I'll order this. So that's as far as we can go for now. And all right, hopefully this will turn out a little bit better as promised with the schematic. So here's the antenna in right here at the very beginning. And here's the potentiometer, basically the volume switch at the very beginning right here. And as you can see, what it does is it would attenuate any input signal. That's the only volume switch for that, for the signal coming in. So what we did was we put a signal here, and we fed it through this transformer here, and we were able to do it all the way up to here to the grid without the power on, because nothing here is powered up. So we put a signal, or I put a signal in and checked it all the way to here without the power on. We had a good signal, and then with the power out, we had a lot of noise, but we had a good signal at the grid of this tube right here. Well, now we didn't have that tube in. I was putting them in one at a time to try and eliminate some noise. So if we would have checked for the noise on the transformer side, we would have got a lot of hum. But when it passes it over onto the grid side of the next tube, that's when we got a good signal. Albeit it was off frequency a little bit, because each one of these is a different section on the tuning cap. And if you look here too, it has little what do you call them, trimmer caps for all of the tuners. So that'll be helpful too. That'll help get us an even stronger signal. So anyhow, we had the signal here, and then we checked, and here we had this was off frequency, or we were bringing up some hum, and it was off a good amount. However, when we checked basically at, where did we check? I believe, yeah, we were right there. We checked at the plate of 27. We had a nice strong signal. Now this transformer here is fried. The secondary is fried. That was because what happened was when this guy over here, when this capacitor shorted, that B basically had a whole lot of voltage on it. So that fried that, and it also fried, where is it? Which transformer would it be? I believe it'd be this transformer right here, number 8. Now the numbers could be wrong, because there's a whole bunch of different schematics for the Model 20. I did have to replace some resistors because they were way out of tolerance according to what the parts list had. Now I'm looking on this, and I noticed that this had different values actually in the circuit. But anyhow, so this is the transformer that's bad here. This is the one that I just ordered, and we have a signal coming into that transformer, nice strong signal, so we should have an even stronger one coming out. And then once we get that, we'll be able to do the alignment on everything. And we'll see what happens with the voltage on, this is the detector right here. And I have uncommonly high voltage on the plate of that. So we'll see what the effect of that is once this transformer's back in and working. Let's see, a couple other things. This was the power supply caps, this guy right here. I was reading some articles. A lot of people recommend not using electrolytics in here. So I may actually just take the electrolytics out. Those weren't electrolytics that were in there before. However, you can see here, these are marked with polarity. The original schematics did not have the polarities marked on them. We'll try either way and see what happens. All right. that's it. I just wanted to show you the schematic as I've been trying to do this. But first the computer wasn't running, and then I'm using this GoPro. It's a little bit harder than my other camera. So, all right. We'll be back. So thanks for watching, and we'll pick up on this in the next exciting episode. Let me turn off my signal. Let me turn, so we're not polluting the airwaves, and we'll turn off the radio, and we'll turn off the tester, and we'll turn off the voltmeter, and goodbye.